and jailbreak. Just simply fill in the online surveys form during this 2 days event. You should see the survey link at this virtual conference room. Please refer to the guideline there to fill in the survey. We will announce the winner at our Hong Kong Open Source Conference Facebook fan page on June 19, Friday. Well, welcome to our conference again. Coming topic is Surface Mesh on OpenShift by Mr. Frankie Ng. Mr. Frankie Ng is a senior solution architect in Red Hat. He was focusing on OpenStack and SDN technologies. Previously, Frankie served as a cloud engineer in TechCom and LED, the development in AAS platform. Frankie received his Master of Science in Information Engineering from Chinese University of Hong Kong. According to Frankie, the term surface mesh is used to describe the network of microsurfaces that make up the applications and interactions between them. In this section, he will take a look at the ISTIO and how it provides behavioral insights and operational control over the surface mesh as a whole. Let's welcome Mr. Frankie Ng, Surface Mesh on OpenShift, Mr. Frankie Ng. Thank you.
Okay, good morning, everyone. This is Frankie from Red Hat. Today, I'm going to talk about surface mesh. What is surface mesh, and what scenario you're going to use surface mesh. So before going to surface mesh, I have to talk about what is microservice architecture. So when you take a look at the traditional microservices or application design, microservice approach is try to break down single application into different services. Each is independent of each other, such that they can deploy independently. They can have their own programming language. They can have their own data storage technology. So that's why we call it microservices. In another way, you can think that microservices is a distributed architecture. So when you have more and more microservices, you can think that what used to be an API call inside the code level, now it's become an API call over the network. So that you can see that you will rely more and more on the network SLA. But I would say that there is a wrong assumption about the network. A traditional programmer, developer, always think that the network is reliable, the latency is low, there is infinite bandwidth. But in reality, that's not true. That's why we need to separate the network layer with the application layer. So as a traditional network guy, if I want to know more about the microservice topology, I want to introduce some functionality inside that service, such as the routing, such as circuit breaker and distributed tracing. I want to discover what is service inside the application. But however, when you try to couple or bundle that service inside that application, it's already result in application refactoring. It already leads to some incompatibility. So it is, I would say, it's an operation nightmare. So what I'm trying to do is to separate an application architecture in the server layer. First of all, I want to separate the service layer. Inside this area, we have to increase the application topology. We want to introduce some kind of feature like fault tolerance, service security, chaos setting, and traffic control. And the underlying technology, for example, like the service operation, infrastructure operation, we will include the traditional log and monitoring, load balancing, how to do the configuration or release management. And under the fourth layer is the infrastructure layer. That means you want to build or deploy your application anywhere. There should be a multi-tenant feature, like you want to isolate your network, you have a precision storage. So we need to have different tools for different layer of services. For example, what we're going to talk about is the first layer, that is the service layer, okay? It can be handled by Istio service mesh. We will cater some feature like load balancing, fault tolerance, service security, traffic control, etc. And then I try to decouple it from the traditional service and infra operation, which means the service and infrastructure operation should be handled by an enterprise-grade Kubernetes. We will try to orchestrate the underlying resources like the load balancing, the build resource management, how to deploy, etc., etc. And then the fourth layer should be handled by a traditional infrastructure like your bare metal, virtual cloud infrastructure, or public cloud and private cloud. So what we want to discuss today is the Istio service mesh today. That is how to help you to cater the service layer. So in short, what is service mesh? In one sentence, it is a decentralized application network infrastructure, so that to help your microservice to communicate with each other. What can I do with Istio service mesh? I think the most important thing is it gives you overall application topology. Okay, like once you have the network topology, you know what's happened there, and then you can take control it. For example, you can control the security and policy enforcement, you can build service resilience, and you can do chaos testing. And then what makes up of a service mesh ecosystem? I think the core component, the core essential component is Istio. It's based on an open source project called Istio. And then around Istio, there is a service that shows you the distributed tracing, which is called Jaeger. And then we have Kiali that shows you the network application topology. And then, of course, we have Prometheus and Grafana to show you the alert and monitoring. And here is the Istio service mesh architecture. In a traditional way, you can imagine two servers, like service A container pod try to communicate with server B container pod. They will use, they will over the network, they will over the SDN network. But once you introduce service mesh, it will inject a sidecar, which is called Istio proxy. In Istio term, it's called an envoy. And once you introduce this kind of Istio proxy, it will intercept the communication between the two containers. They will communicate with each other using HTTP protocol, gRPC, TCP, and also usual TLS. So this makeup of the data plane of the Istio service mesh. And then we have a control plane that consists of three essential components. The first one is called pilot. We will inject the container policy inside the Istio policy. And then we have another component called mixer that's responsible for the telemetry. It will connect metrics from the Istio policy such that you can have visibility of what's going on. And then you can define quota. And then the last thing is Citadel, which is responsible for the certificate and identity management. So when we talk about Red Hat OpenShift service mesh, actually it's this combination of Istio, Jaeger, Kiali, Prometheus, and Grafana. And it's based on an upstream open source project called Mister. I encourage you to take a look in the GitHub here. And then beside that, we like make it very easy to deploy. We use a framework called operator framework so that you can click servo button and then deploy all the service mesh in OpenShift. Okay, let's take a deep dive into service mesh. The first one is many people use Istio to do monitoring. For example, in this diagram, you can see that I can collect log and metrics from the Istio policy, and then it will send to the control plane. And then all the information will be passed through the Prometheus adapter and then sent to Grafana for display. The second important feature is Kiali. We will show you the, I would say, the application network topology. In this diagram, you can see that I have a microservice application here. It consists of a customer version 1, preference version 1, and then there are two versions of inside recommendation. And I can see what is the relationship between these microservices. And also, it can show you the health status about that container. And then the second thing is tracing. And in service mesh, we call it Jaeger distributed tracing. The idea is similar to what Kiali do is it will collect trace record from the Envoy proxy, and then it will send to control pane and then display in the Jaeger web interface. What it can do is it will provide you the processing time of your end-to-end communication. For example, from service A to service B to service C, you can have brief idea around what is the processing time of the overall end-to-end. Like for this example, it's over 900 milliseconds. And then you can see that the bottleneck is actually inside the communication between service B and service C. It's take over 700 milliseconds. And then traffic control. I think one of the major benefits of Istio is bring you Canary deployment. The idea behind Canary deployment is you can spin up a new version of your service, and then you can slightly migrate some of or part of the traffic to that microservices, test the behavior, and then if anything go wrong, you will roll back to version 1. Like in the example, we have two communications here. That is service B version 2 and then service B version 1. I want to do a Canary deployment such that all the employee log in, it will go to service B version 2, and then everyone else will go to service B version 1. Another scenario is weighted routing. In the example, you can see that when I spin up a new version 2, I try to send only part of service traffic to that version 2, like 5% of traffic. And then if things go fine, I can increase the traffic to 50% and finally migrate all the traffic from version 1 to version 2. And then another major benefit is you can have a dark launch using Istio. Like by default, I will send 100% of traffic to version 1. But at the same time, I will mirror or shadow that kind of live traffic to version 2 so that you can test the behavior in version 2. If everything go right, and then you can migrate from version 1 to version 2. Okay, service security. And you can secure all the communication between the microservices using MTLS. And I would say compared to the traditional TLS, MTLS or mutual TLS is actually authenticate both client and server. So when I would say it's still possible try to initiate and handshake to the server. It will authenticate both the I would say the service account inside the certificate. Okay, I will check whether I will authorize to communicate with this kind of service. If I check that I pass the blame check, I'm authorized to communicate with that kind of service, I will encrypt all the service with TLS. Otherwise, I will drop the package. And also, you can control the service access with Istio. Like in this example, service A can only allow communicate with service B, but not directly communicate with service C. And then fault tolerance. So another benefit of Istio is there is a feature called circuit breakers. In the example, you can see there's two routes going to service C. You can go through service A, service B, and then service C, or service A and can communicate directly with service C. If anything happens, you can reroute the traffic. And also, you can inject timeout and retry value. Like in this example, I inject a 50-second timeout value and then 5 retry value between the communication in service A and service B. And also, you can rate limiting the maximum connection. So before I go to demo, this is the last part, is chaos engineering. So in Istio, it's called fault injection. So you can inject some kind of unexpected situation inside this microservice communication. For example, I will inject a 10-second delay in 10% of all of my requests. Or I can ingest HTTP 400 in 5% of the requests. So that is what you can test your behavior, test what happened in this, your application. So I will give a little demo on some use cases. The demo environment is like this. I have a microservices deployed on OpenShift. is consists of a certain component. The first one is product page, is written in Python. And then we have 3 versions of reviews. It's written in Java. You can see that we have review version 1, review version 2. We will show you it's backstar. And then we have review version 3 with red star. So and the last part is we have a detail page. The application is actually look like this. Okay, when I click refresh, you can see that it's a product page here, and then I have book details here, and then I have book review here. And then when I refresh, it will go to 3 different versions. Like there is a red star, that means it is review version 3. And then I keep refresh it. You can see backstar, that means review version 2. Okay, what it actually look like in application topology. I will show you the Canary diagram. So here is what it looks like. So you can see that we have traffic pumping in that application, and then it go through product page, and then it go to details, and then it will go to review. Now, all the traffic are evenly distributed around version 1, version 2, and 3, so that each of them is 33%. And when you click on it, you can see that on the right-hand side, I have some more detailed information, like what is the protocol, is HTTP request, and then what is the response time. And you can also configure the diagram, like I can show what is the request per second, and then also what is the response time. You can see, it's like it's 24 seconds for the product page, and then the response time for review 1, version 1 is 5 milliseconds. So this is what you can see in Canary through application network topology. And then what I'm trying to do is try to manipulate, I try to modify the routing policy inside this application. So what I'm going to show you first is I have a YAML file here. I want to show you that now what I'm going to do is I try to while 80% of the traffic go to version 1, and then 20% of traffic go to version 2. Why I'm doing this is I try to simulate. I want to upgrade from version 1 and version 2, and then I gradually send 20% of traffic to version 2, test its behavior, and then if everything go right, I will complete migrate to version 2. So if I'm going to apply this file, it's very simple. I just go to command line, and then I apply a weighted routing YAML file. So you can see it's created. And then when I go back to the sample application, I try to refresh it, and then you can see around 80% of traffic will go to version 1. That means it is no star here. And then our 20% of traffic will go to version 2, that is red star. And you will no longer see the red star review here. What's it look like in Canary is actually look like this. You can see that before I modify the policy, the traffic should be evenly distributed around version 1, version 2, and version 3. Now, you can see that there are around 66% of traffic go to version 1. And then it's gradually become 80% and 20% distributed. So this means that my policy is configured right here, and is applying the policy. So after I test something, I want to simulate that the application version 2 look good, and then I want to migrate all the traffic from version 1 to version 2. So what I'm going to do is I apply traffic all to version 2. Okay. And then what is the actual YAML file look like is over here. Version 2, yep. And then you can see that I will reroute all the traffic to version 2 here. And then when I refresh the application, it will no longer go to version 1 or version 3. It will only go to version 2. So it is say here is best star. Okay, and then when you go to the Kiali, you can see that the traffic pattern is gradually increased in version 2 from 20%, and I would say eventually it will become 100%. Yeah, here we go. Okay, and then the next thing I'm going to show you is I will try to do the policy routing based on the user identity. Okay, for example, I have a user called Jason. Okay, I will check that if the HTTP header match the user Jason, and then it will route all the traffic to version 2. Anyone else will go to version 1. So version 2 match Jason, and then everything else will match version 1. That's what I'm going to do. So in the command, in the control plane, I try to apply this kind of policy. Yeah, here we go. Let me go to the application page. And this time when I try to refresh, you will see that I can only go to version 1. Version 1 is no star here. And then when I simulate a user called Jason login, Jason sign in, and then you will see that I will only go to version 2. When I log out again, it will go back to version 1. So this simulate how you use the user identity to do routing. And then the last thing I'm going to show you is how to encrypt all the traffic. Let's go back to here. Make sure everything all right. And then what I'm going to show you is I try to encrypt all the traffic between the microservices. So what I'm going to do is to apply this YAML file. In this YAML file, you can see that for each communication in the microservices, I insert a traffic policy here that is using Istio Metro TLS. And then I insert this kind of code in all of the microservices communication YAML file, like this. And then let me show you. Okay, here we go. And then when we go to the Kiali service, you will see that nothing happened right now. But after several seconds, you will see that all the traffic will be encrypted with TLS. So let's wait for a few seconds. Yeah, here we go. You can see that there is a knock over here. Okay, when you click on it, you can see that all the traffic is encrypted by MTLS. So another things I want to show you is distributed tracing. Okay, we do the distributed tracing report using the Jaeger UI. So in here, let me refresh it. You can see that we have diagram here. We've shown you the x-axis is the time, and then the y-axis is duration. I would say it's processing time. And I see that there is a pipe here. I don't know why there is a sudden increase in the response time. So when I click on it, you can see that, oh, the end-to-end response time is lasts for 41 or 42 milliseconds. And then most of the time, it is in the product info page. It takes a long of time. And then when I click on it, it will show you what happened there. For example, like what is protocol, what is user agent, what is the HTTP method, and then you can do some troubleshoot based on this information. So this is the end for today's presentation. I hope I give you a brief introduction about what is service mesh and what is its use case. I strongly encourage you to take a look at the upstream Istio project and try to contribute more and make it better. So thank you very much. See you. Bye-bye.